Chapter 5, number 27. Identify the maximum and minimum of f of x. F of x is equal to negative 1/4 x to the fourth plus 3x cubed minus 10x squared plus 40. We're going to use the first derivative test in order to solve this. The first derivative test finds the antiderivative of f of x, which is equal to bringing down the exponent and timesing that by this first variable in each of the parts. So we will get 4 times negative 1/4 x, and then we do the exponent minus 1. So 4 minus 1 plus 3 times 3x to the 3 minus 1 minus 10 times 2x to the 2 minus 1. When we have a variable like this where it's 40 with no variable x or any variable attached to that, we know that this is a variable to the 0 power, and 40 times 0 is equal to 0, so we can just leave that by itself. Then we can simplify this to negative x to the third plus 9x squared minus 20x. In order to do the first derivative test, we also have to set f prime of x equal to 0. Now to use the first derivative test, we'll set f prime of x equal to 0, so 0 equals negative x cubed plus 9x squared minus 20, and then we'll factor. We can factor out a negative x, so we factor out negative x and get x squared minus 9x, minus 20x, minus 9x plus 20. We continue to factor this, and we get that negative x, and then x minus 4, x minus 5. Continue to factor negative x. And in this part, when we factor, we can set each part to 0. So 0 equals negative x, 0 equals x minus 4, 0 equals x minus 5, and solve for x. We get that x is equal to 0, x is equal to 4, and x is equal to 5. These three values that we get from the x is equal to 4, x is equal to 0, and x is equal to 5, that should be a 5, we then get critical points, which we'll use for the first derivative test. Once we get our critical points, we're going to put them on a number line, 0, 4, 5. Then we're going to plug in these certain values to f prime of x. So put one value that is less than your first number, so say negative 1, and that gives us a positive value. Then plug in one value between 0 and 4, say 3, that gives us a negative value. Plug in between 4 and 5, say 4.5, we get a positive value. And plug in a value that's larger than 5, and we get a negative value. Then we're going to take these critical points, and we're going to, once we know where f prime of x is positive or negative, we can then look at f of x and find where it's increasing. So if it is positive, we know that it is increasing. If it's negative, we know it's decreasing. If it's positive, again, we know it's increasing. Negative, decreasing. Then you can almost connect, and I like to draw the line so that we can visually see it. And we know if we connect these lines then, like this gives us a max. Here gives us a min and a max. So then we take our critical points at 0, and we plug that into our original f of x, and we get this point of 0, comma 40, and then we get a minimum where we plug in 4. We get 4, comma 8.75, and a max at 5, comma 8.